This is example 5, and if you look at the models we were given, this is actually the logistics growth model. So it says, on a college campus of 5,000 students, one student returns from vacation with a contagious flu virus. The spread of the virus is modeled by that equation, where Y is the total number of infected after T days. So first, how would we find how many people are infected after 5 days? Plug in 5 for T. So Y of 5 would be 5,000 divided by 1 plus 4,999 e to the negative 0.8 times 5. I mean, that is straightforward. Just put it in the calculator to do everything right. Make sure that your denominator is in parentheses, right? Otherwise, you're not going to get the right answer. And if you do that, you're going to get approximately, rounded to the nearest student, 54 students are infected after 5 days. Okay. How many? Notice how the formula would have worked. If you check it out, the initial is usually when you plug in T equals 0, right? So if I plug in a T equals 0, then I would have had e to the 0, which is 1, which makes 1 plus 4,999 is 5,000. So 5,000 over 5,000, 1 was infected initially, which is right. Right, what is what number will it approach? What's the maximum number? There's only 5,000 students on campus, according to the problem. Well, as this number gets bigger and bigger and bigger, since this is a exponential decay, this whole term will go to 0. It'll approach 0 if you let the t get really big. If this goes to 0, then the value is 5,000. So it's going to max out at 5,000. It'll approach y equals 5,000 like an asymptote, like we saw in the logistics growth model, right? It grows fast, but then it levels off at the end. Okay. Well, it assumes that there's no other things going on. Like they don't do something to try to, mitigate it. They don't introduce some vaccine or something. Okay. The second part, the college says that it'll cancel classes when 40% or more of the students are ill. There's 5,000 kids on the campus. What's 40% of 5,000? It's 2,000. So basically, the second part of the question is asking, when will y equal 2,000? As this grows, when does it hit the 2,000 mark that they're going to cancel classes? So what should we do with that? Plug 2,000 here. So we go here, 2,000 equals 5,000 divided by 1 plus 4,999 e to the negative 0.8 times t. Okay, now you got to solve for the t, which is buried in the denominator there. Multiply by what? See any? The denominator, right? You multiply both sides by this denominator. This cancels and it moves it here. Then what? Then you divide by the 2,000. Basically, these two are going to swap. You'll have 1 plus 4,999 e to the negative 0.8 t equals 5,000. Oh, this is starting to really goof up. Okay. Let's erase that one. Let's erase that one. Equals 5,000 over 2,000. Okay, which is 2.5. So now we've got 1 plus 4,999 e to the negative 0.8 t equals 2.5, right? This is an exponential, so we're going to have to isolate the exponential, subtract 1. equals 1.5, divide by 4,999, and then take the log of both sides, right? So we'll get negative 0.8t equals natural log of 1.5 over 4,999. Okay, take the natural log of e, what do you get? The exponent. Okay, divide by negative 0.8. Yeah. Okay, and that equals 10.14. So in about 10 days, they would expect to go over that magic 40% and have to close the campus. Unless they do something, like I say, you know, this is like the raw, I guess what they think is going on. I'm not sure whether that factors in something that they might have done to prevent it.